Imagine a place where all the stuff in the universe, every star, every planet, every speck of dust, gets squeezed into an impossibly tiny spot. This spot is what scientists call a singularity. It's a point of infinite density. That means an unimaginable amount of mass is packed into a space with zero volume. Think about that for a moment. Zero volume, yet holding everything. It's a concept that really stretches the mind. Our everyday understanding of space and stuff just doesn't apply here. It's a truly extreme cosmic condition, unlike anything else we know. Now, when we talk about singularities, we also have to talk about the rules of the universe. These rules are what we call the laws of physics. They tell us how gravity works, how light travels, and how particles interact. But at a singularity, these laws break down. They just stop making sense. It's like trying to divide by zero on a calculator. The calculator gives you an error message because the operation is undefined. In a similar way, our current physics equations give us nonsensical answers when we try to describe what happens right at the center of a singularity. This is a huge puzzle for scientists. Gravity plays the lead role in the story of singularities. Normally, gravity is the force that keeps your feet on the ground and planets orbiting stars. It's a gentle pull for the most part. But near a singularity, gravity becomes unimaginably strong. It's so powerful that it warps the very fabric of space and time around it. Think of space-time as a cosmic trampoline. A bowling ball placed on it would cause a dip. A singularity is like an infinitely heavy object, creating an infinitely deep well in that trampoline. Nothing, not even light, can escape its pull once it gets too close. Let's try another way to picture this. Imagine you have a giant mountain, bigger than Everest, made entirely of solid rock. Now imagine you could somehow crush that entire mountain down until it was smaller than a grain of sand. Then, keep crushing it further until it's smaller than an atom, and then even smaller, until it occupies no space at all, yet still has all its original mass. That infinitely dense speck is akin to a singularity. It's where the known universe, with all its vastness, could theoretically end up if it were to collapse upon itself. It's a mind-boggling thought. So where do these extraordinary points of infinite density actually come from? The most well-known places we expect to find singularities are at the hearts of black holes. Black holes are cosmic vacuum cleaners, but they start their lives as giant stars. These stars are much more massive than our own sun. Throughout their lives, they burn through their nuclear fuel, creating heavier elements in their cores. This process generates an outward pressure that balances the inward pull of their own immense gravity, keeping them stable for millions or even billions of years. However, all stars eventually run out of fuel. When a truly massive star exhausts its nuclear reserves, the outward pressure from fusion suddenly stops. There's nothing left to fight against the relentless crush of its own gravity. The star's core, which can still be incredibly massive, begins to collapse catastrophically. Imagine a building whose support beams are all suddenly removed. The entire structure implodes. This stellar collapse happens incredibly fast in a matter of seconds. The outer layers of the star are often blown away in a spectacular explosion called a supernova. What's left behind after the supernova is the super-dense core. If this core is massive enough, typically more than about 3 times the mass of our sun, gravity will continue to crush it relentlessly. No known force in the universe can stop this collapse. The material gets squeezed tighter and tighter. Electrons and protons are forced together to form neutrons. If the mass is still too great, even the neutrons can't resist the crush. The core continues to shrink, becoming denser and denser, hotter and hotter, until it collapses all the way down to that infinitely small point, the singularity. Think of it like this. Imagine you're squeezing a sponge. You can squeeze it quite a bit, making it much smaller. Now imagine you have a super strong squeezing machine that can compress that sponge until it's smaller than a marble, then smaller than a pinhead, and then, theoretically, until it has no size at all but still contains all the sponge material. That's what gravity does to the core of a massive star to form a singularity. It's the ultimate cosmic compression. driven by the most powerful force in the universe over incredibly small scales, leading to a point of infinite density. We've talked about singularities forming from individual stars, but what if the entire universe itself could collapse into one giant singularity? This is a theoretical possibility known as the Big Crunch. It's like the Big Bang, the event that started our universe's expansion but playing out in reverse. Instead of everything flying apart, everything would start coming back together. This idea hinges on the overall density of the universe. If there's enough matter and energy, its collective gravity could eventually overcome the universe's expansion. For a long time, astronomers debated whether the universe had enough stuff in it for this to happen. This stuff includes not just the stars and galaxies we can see, but also dark matter and dark energy. Dark matter adds to the universe's gravity, while dark energy seems to be accelerating the expansion. If the force of gravity, boosted by all the matter, visible and dark, were strong enough to eventually halt this expansion, then the universe would reach a maximum size. After that point, it would begin to contract, slowly at first, then faster and faster. As the universe contracts, galaxies would start to merge. The space between stars would shrink. The cosmic microwave background radiation, the afterglow of the Big Bang, would get hotter and hotter as it's compressed. Stars would get closer to each other, eventually colliding and merging. The universe would become an increasingly dense and incredibly hot place. It would be a chaotic and violent environment, dismantling all the structures that had formed over billions of years. Planets would be torn apart, stars vaporized, and black holes would gobble up everything around them, growing larger and larger. Imagine blowing up a balloon. As you blow air in, the surface of the balloon expands, and any dots you drew on it move farther apart. This is like our expanding universe. Now imagine you start letting the air out of the balloon. The surface shrinks and the dots move closer and closer together until the balloon is completely deflated into a small, crumpled piece of rubber. The Big Crunch is a cosmic scale version of that deflation. All the matter and energy in the universe would rush together, heading towards a final, all-encompassing singularity, recreating conditions similar to those just before the Big Bang. If the entire universe were to collapse into a singularity, what would that mean for the very fabric of existence? Space, as we perceive it, the three-dimensional expanse in which we live and move, would cease to exist in any recognizable form. The concept of distance would become meaningless, because everything would be at the same single point. All locations would merge into one. The vast emptiness that currently separates galaxies, stars, and planets would be gone, compressed into that infinitesimal singularity. It's hard to even imagine. And what about time? Time is intricately linked with space in Einstein's theory of relativity, forming what we call space-time. If space collapses, time would likely undergo a profound transformation as well. At a singularity, the equation suggests that time itself might end. The relentless forward march of moments from past to present to future could come to a halt. Or perhaps our understanding of time is too limited. Maybe time behaves in ways we can't yet comprehend under such extreme conditions. The very notions of before and after the singularity could become undefined. All the matter in the universe, every atom, every particle that makes up you, me, the earth, and the stars, would be crushed beyond recognition. The fundamental forces that govern how particles interact would be overcome by the immense gravitational forces. Protons, neutrons, and electrons would lose their individual identities. The very building blocks of matter would be squeezed into an undifferentiated state, a plasma of fundamental particles, and then further into something even more exotic, eventually becoming part of the infinitely dense singularity. Everything would be reduced to its most basic essence. What would happen then? Could a new universe emerge from this cosmic singularity, perhaps in another Big Bang? This is a fascinating area of theoretical physics, with ideas like a big bounce, where the universe collapses and then re-expands, potentially in an endless cycle of creation and destruction. Or perhaps it's a one-way trip to oblivion. The truth is, we don't know. A universal singularity represents the ultimate unknown, a point where our current scientific understanding reaches its absolute limit, pushing us to seek new theories to describe the beginning and perhaps the end of everything.